axis. Now the object is at twice the first focal point. Object is at the twice the first focal point. Okay. So AB is the object here, and from the object, the two rays I draw. A ray parallel to the principal axis, after reflection passes to the second focus. Again, the ray of light passes to the optical center without any deviation. It emerges out to the lens. So now these two refracted rays, they will meet at point somewhere here at this point. So this point will, at this point, the image will be formed. That means the image is formed at twice the second focal point. So what is this actually twice the second focal point is? So here it is f2, then after that 2f2, then 3f2, 4f2. That means you go on increasing. Okay, you go on writing that after f2, 2f2, 3f2, and so on. Likewise here also f1, 2f1, 3f1, 4f1, and so on. Okay, so don't get confused. Why I am writing 2f2 and 2f2 is not here, but why it is written here? Okay, so just to denote here, just to denote the focal point. Now, when the object is at twice the first focal point, the image is formed at twice the second focal point. Remember this. When the object is at the twice the first focal point, image will be at the second focal point. Now, the image is real, inverted, and same size of the object. The size of the image will be same as the size of the object. Inverted image is formed and real images are formed. Because why real image is forming, you know that? Because the refracted ray, they will intersect, they will meet at one point. Okay? Now this type of image formation are used in terrestrial telescope. These are used in a terrestrial telescope. Okay? And the second one, now this one. Now the object is beyond the twice the first focal point. That means where is the object now? The object is beyond the twice the first focal point. So when the object is beyond the twice the first focal point, now the image is forming between the focal point and the first focal point and the twice the second focal point. That means in between, the image is forming in between the f2 and 2f2. The same ray diagram will draw it. Okay, one parallel to the principal axis. After refraction passes to the focus. That is the second focal point. When the ray of light passes to the optical center, it emerges also in the optical center without any deviation. So the ray of light will meet at this point. Okay, and this point will become as the image of the object AB. And this image is smaller. That means the image is smaller than the size of the object. That is the diminished image will be formed here. The image is real since the refracted ray are intersecting, they are meeting at a point. Inverted images are forming and diminished images are formed. Okay. Now this is the formed image when the object is placed beyond the second twice the first focal point. Now this type of image formation are used in formation of photographic camera. These are used in the formation of photographic camera, whereas this type of image formation are used in terrestrial telescope. Okay. Now the third one comes a ray of light parallel to the principal axis. These are the rays of light which are parallel to the principal axis. After refraction, all the rays of light, they will meet at f2. That means at second focal point. So therefore, the image is very small. The image is like a point. Okay, a very small image is formed. That means highly diminished images are formed. That means real, inverted, and highly diminished images are formed. And this type of image formation are used in burning glass. Okay, so you take a burning glass, you take a paper, okay, and you just take that glass in front of the paper. All the light rays from the sun, they converge and they will converge and they will intersect at one point of the paper, and therefore the paper, it catches fire. So these are used in the burning glass. And the last one is here, the ray of light coming from infinity. Okay, that means the object is at infinity. Consider the object is at infinity. Okay, when the object is at infinity, then the ray of light from the infinity, one ray of light it passes to the optical center, another ray of light it passes to the focus. When the remember one point here, when the ray of light passes to the focus, either it can be a first focus or the second focus, okay, F2 or F1. After refraction, it goes parallel to the principal axis. That means this is just opposite. When the ray of light is parallel to the principal axis, after refraction, it passes to the focus. But here, when the ray of light passes to the focus, after refraction, it goes parallel to the principal axis. Remember that. So this ray of light coming from the source, okay, the object is at infinity. The ray of light passes to the focus, that means from the point F1, and after refraction it goes parallel to the principal axis. And therefore, the image is formed at F2. The image is forming at F2. And here also the inverted images are formed, real image, inverted images are formed. And this image and diminished images are formed. The image is very small compared to the size of the object. Okay, and this type of image formation are used in the formation of telescope. So this is about the image formation in case of a convex lens. In the next class, we will come to the few points, the few ray diagram related to the concave lens. Thank you.